Hello everyone, so welcome to the 5th GCSE Chemistry online lesson for St Leonard's Academy students. And the learning question for this lesson is, how do I separate liquids? Now what I'd like you to do, if you don't have a pen or a pencil, and if you don't have either a piece of paper or a notepad, then I'd like you to just pause the video and go and grab those now. Great, well done. And what I'd like you to do is write the learning question, how do I separate liquids? And the do it now for this lesson is a little bit of revision of what we looked at last lesson, so states of matter, and a little bit of revision of what you would have looked at earlier on in Key Stage 3. Okay, so what I'd like you to do, please, is copy down these definitions in blue and match them up to the correct keyword, please. So pause the video now and take a few minutes to do that. Excellent, well done. So attractive forces are the weak forces of attraction between molecules. The melting point is the temperature at which a substance changes from a solid state to a liquid state, so the point at which it melts. An atom is the smallest neutral part of an element that can take part in chemical reactions. And the boiling point is the temperature at which a liquid boils, so the temperature at which it changes from a liquid to a gas. So if you need to correct any of your definitions, then just take a moment to do that now. Fab, well done. So this is the piece of equipment that we are going to be looking at today. So this is the apparatus that we use to carry out a process that we call simple distillation. And simple distillation can separate out a mixture of liquids, because those liquids will have different boiling points. Or it can separate out a liquid from a solid if you want to keep the liquid and the solid. So for example, if you had a mixture of salt and water, so like seawater, so say you had a cup of seawater, you wanted to separate out the water from the salt in that mixture, then you could use this apparatus and you could use the process of simple distillation to do that. So in a moment, we are going to watch a video which explains how the process of simple distillation works. But what I would like you to do first of all is pause the video and have a go at sketching out this set of apparatus that we call a Liebig condenser. Okay, if you have a ruler and a pencil, then it would be really great to use those, because then it would be a nice neat diagram of the Liebig condenser apparatus. But if not, then just sketch it out best you can. We are going to be using this diagram to label it and take some notes on the process of simple distillation. So you really need the diagram in front of you. Okay, so if you can pause the video now, have a go at sketching out this diagram of the Liebig condenser, the apparatus that we use for simple distillation. Brilliant, well done. Okay, so as I promised, we have a video now that is going to explain to us how simple distillation works.
So distillation can be used to separate a liquid from a solid if we want to keep the liquid. Now, I should point out that we call this simple distillation. There is another technique called fractional distillation, and this allows us to separate two different liquids. We're going to look at fractional distillation in the next video. So how does simple distillation work? Well, there are two stages to this process. First, we evaporate the liquid by heating. We then condense the vapor back to a liquid by cooling.
Okay, so this is touching on what we were talking about last week. So when you heat a liquid, it will evaporate. And when you cool a gas or a vapor, it will condense. So these are the two really important processes of evaporation and condensation that we need to understand in order to understand how simple distillation works. And you'll be able to see where these processes happen in simple distillation in a moment.
Let's look at the apparatus that we use to do this. We place our solution with the liquid and the dissolved solid in this flask here. This flask is now connected to a continuous glass tube, which I'm showing you with this yellow arrow here. The glass tube is surrounded by a jacket, which we call the condenser. Cold water from the tap continuously runs through the condenser, and by doing this, it keeps the internal glass tube cold. After running through the condenser, the water simply goes down the sink. We've also got a thermometer as part of the apparatus here. So let's see how this works. We start by heating our solution, for example, by using a Bunsen burner.
So if you've ever carried out this practical at school in a lab, then you would have used a Bunsen burner to do it. So the mixture here is heated.
We heat the liquid, it starts to evaporate, turning into a vapour. This vapour now rises up the glass tube like this.
So rises up here.
The thermometer shows us that the temperature is rising, but actually with simple distillation we usually just boil the liquid. The vapour now passes into the condenser. Remember that the condenser is kept cold because we're circulating cold water around it. This means that the vapour now condenses, turning back into a liquid as it passes through the condenser like this. We can collect the liquid in our beaker, so at the end we're left with crystals of our solid in the flask.
Okay, so just to go over that, so the mixture is heated here. The liquid will evaporate and rise up through the glass tubing. Then at this point, it will travel down the condenser, and as it does, it will be cooled and it will turn from a gas or a vapour back into a liquid. And the reason why it is cooled is because cold water is pumped into this jacket. So the jacket just surrounds the condenser so that it can help to cool down that gas and condense it back into a liquid.
Here, and our liquid is in the beaker here. So that's simple distillation.
There we go. So that is simple distillation. So if I take us back to our PowerPoints, we can look at our diagram of the Liebig condenser. What I would like you to do on your diagram is try and label. So first of all, just label the different parts of the Liebig condenser. So pause the video now. If you need to go back and just look at that explanation again to look at the names of the different pieces of equipment, then you can do that. But I'd like you to label your diagram of the Liebig condenser, please. Excellent, well done. So you've got the thermometer. You usually have a bung or a cork there to stop any of the vapour from escaping. You've got the heat source or the Bunsen burner here. You've got this flask here with your mixture in. This column here, this tube here, is the condenser, and you've got this water jacket around it where cold water is pumped in, and the water comes out here, and the water there will just carry on and flow down into the sink. Okay, and you've got what we call the distillate here, which in the case of separating salt from water, the distillate would be the pure water that you would collect down here. So if you need to just add any more labels onto your diagram, then just pause the video and do that now. Fab. So what I would like you to do now is look at these 4 definitions for simple distillation. So these 4 explanations of how simple distillation works. And I'd like you to try and pick the best definition, please. And then write it out on your paper or on your notepad. So pause the video and have a go at doing that. Fab. So I think the best definition is A. So the liquid from a solution is evaporated and then it is condensed to collect it. So that's kind of the best, the simplest and the best definition for how simple distillation works. Excellent. Now what I'd like you to do, go back to looking at your diagram of the Liebig condenser. Please can you write an E on your diagram where evaporation takes place, and a C on your diagram where condensation is taking place. And what I'd like you to do, if you feel really confident, is have a go at illustrating evaporation and condensation by drawing a particle diagram to show them, to show what's happening in the particles. So pause the video for a few minutes now and complete those tasks, please. Excellent. So I have on my diagram put an E here because this is where evaporation takes place. So heat, the heat source is underneath the mixture and the water is evaporating. The liquid is evaporating. And I've put a C here because this is where, in this condenser, is where condensation happens as the vapor cools and turns back into a liquid. And the particle diagrams that I found to show evaporation and condensation are here. So here we've got evaporation, so the particles in a liquid are gaining energy, and as they do, as they gain more thermal energy from heat, they're gaining more kinetic energy, they're moving around more, the space between them is increasing, and they're leaving the liquid to evaporate or turn into a gas. And this diagram here is showing what happens in condensation. So those gas particles, they're moving closer together as heat energy is removed. So they've got less kinetic energy until they form back into a liquid. So if you'd like to have a go at drawing those out now, then pause the video and you can do that. Fab. So now I've just got, we're going to pause for a moment, take a deep breath and have a go at some revision questions. So a couple of these are from last week's lesson and also kind of connecting it to what we're learning this week. So can you remember, without looking at any of your notes, what the name of the condenser is? Can you remember which state has the lowest energy? And can you describe what the particles in a solid are like? So try and do this without looking at any of your notes, just to see what you can remember. So pause the video now, have a go at answering those 3 questions. Excellent, well done. So the name of the condenser that's used in simple distillation, we call it the Liebig condenser. Which state has the lowest energy? That's a solid. And describe the particles in a solid. Well, if I were to describe the particles in a solid, I would say that they vibrate, they're touching each other and they're just vibrating. They're in a fixed position. There's no space between them, so they're touching. Okay, so that would be my description for the particles in a solid. Fantastic, well done. So the next thing that I would like you to do is to read through this paragraph, which is an explanation of simple distillation. And I would like you to copy it out and try and put in the correct words from the list of keywords at the bottom there. Okay. If you don't feel that confident about writing it out, then what you can do is you can just write out the keywords in the correct order. But it would be really useful to write out the paragraphs because it would be good for revision in your notes. Okay, so if you can pause the video now and complete that task whichever way you would like to do it. Well done. Well done. So here is the paragraph. I will read it out for you and I will put in the correct words. And what you can do is give yourself a tick for all of the words that you put in the correct place. If you need to pause the video at any point just to give yourself a little correction, then that's fine. So to separate out a mixture of ethanol and water, we use a process called distillation. The mixture is heated up and ethanol will boil first because it has a lower boiling point of 78 degrees. The ethanol will turn into a gas and evaporate. As it evaporates, it leaves the flask through the sidearm. Cold water is passed through the Liebig condenser and it condenses the ethanol back from a gas back into a liquid. The liquid ethanol drips down into the collection beaker and the heat energy is transferred from the ethanol gas to the water, which is being pumped through the condenser. Fab, well done. I'm sure there's loads of ticks on your paper there. So well done for sitting through today's chemistry lesson. What I would like you to do now is have a go at this 6-mark question. So this is our last task. So the question is, describe how you would separate a solution of salty water using simple distillation. And it would be great if you could do this. Try and do this without using the notes. If you need to just have a quick look to remind yourself, then that's fine, you can do that. And what I would love you to do is if you could submit your answer on Shobi, so www.shobi.com, and your class code is there for you. If you can submit your answer to this question on Shobi, then a teacher, myself or another science teacher in the department, will be able to give you some feedback for it and mark it. And we are really, really enjoying receiving your answers. Okay, well done. So, well done again for sitting through this lesson. Well done for being motivated enough to complete the tasks. Have a lovely week. Hope you are all really well. And I will see you next week.